Everybody should go to this website. That's where I'll do the examples. For SQL, it's really easy. You just need a web browser and go to their website. Should be able to click Run SQL, and then you just get the results. So we'll talk about SQL today, structured query language. Basically, it's database. When you go today to any website like Facebook, Instagram, TikTok, whatever you use today, or even desktop applications, it's very likely it is using a database to store all the information that you see. For example, when you fill your profile, you have your name, right? You have some links, you have your description. Where does that information go? Well, ultimately, it goes behind the scenes to a database, and that's where it is stored so that next time you access the website, it remembers all of that. So the most popular way of storing data is via SQL. It's like a kind of database. We write in this kind of language called SQL or SQL, and a structured query language. So you can think of this as like Excel. Let me share my Excel window. So it's like Excel. If you ever use Microsoft Excel or Google Sheets or whatever spreadsheet software, you have like rows and columns, right? So in SQL, basically, we're going to have what we call tables. And each table has columns and rows. So the columns, they denote what kind of information. For example, I want to store the first name of somebody. I can say here, first name, right? So I have a lot of people. I can have John, I can have Maria, etc., right? So the heading here would be what we call column for this table. And then we have each row, right? The first row is for a specific person. The second row for another person, and so it goes on. So every row represents a different object or a person in this case. When we go back to Programiz, what we're going to see is on the right-hand side, you see all your available tables for this exercise. So we have a table of customers, and as you can see, we have some columns. And then each row represents a person or a customer in this case. So we got information about the first name, last name, age, and then the person's country. Now, what we typically do with SQL is we always have ID column to identify each row. And it typically is sequential, starting from 1, and then a new one would be 2, and so on. So it's very common. It's a way of uniquely identify that record. So we have a table of orders that's just for orders. Okay, somebody ordered a keyboard, paid $400, and it tells you which customer. In this case, it goes by ID. So if you say customer ID 4, it means you got to go to the customers table and see, okay, the person who has ID 4 is the one that bought this keyboard. And then we got shippings. Okay, so this is all about shippings. You can see shipping of ID 1, status is still pending, and the customer is number 2. So number 2 meaning, okay, I got to go to the customers table and look up who is customer number 2. That's Robert Luna. So as you can see, each table kind of represents a specific piece of information. You cannot have everything like together that are not related. So we separate the customers, we separate the orders and shippings. And if you need to find information across all of those tables, you got to look them up. Like it have it here, like, okay, the customer 4. So you got to always look up in the customers table who that is. Okay, so we got tables, and tables have rows, and they have columns. So in SQL, we make what's called a query to ask about information. So in this editor here, you can write a query, and then you can click Run SQL, and that will run the query and do whatever command you issue that. Okay, so today we have different kinds of flavors of SQL. SQL is a general term to the structured query language, but many companies have implemented their own version. For example, you might have heard of MySQL or Microsoft SQL Server or Oracle SQL, so IBM SQL and so on. Every company kind of make their own version, but it's all ultimately the same standard language. If you learn how to write SQL standard, you will understand how to write a query from any of those flavors. Okay, so let's do a first query. I'm gonna delete everything here, and I'm just gonna go and say select space star space from space customers. So this is my first query. It's very simple. And if you notice, I use different kinds of casings, uppercase, all caps for select, all caps for from. So this is not really necessary, but it's like a naming convention. When we have keywords from the SQL language, we usually capitalize everything. Okay, so what does it do is allows you to get information for a specific table. In this case, the syntax is always to say select and then space. And star means, okay, I want to see all the columns. Space from the right-hand side of from, you have to say the table name. In this case, I have a table called customers. So make sure to use the same casing here. I know there might be some SQL implementations that don't care about upper lowercase, but I suggest you always try to pay attention to the casing. Okay, I'm going to click Run SQL. As you can see in the output here at the bottom, I see the output for the table customers, and it tells me, okay, got several rows. First row being John Doe from the USA, age 31. And then the second being Robert Luna, 22 from the USA, and so on. Okay. So the star here means I want to get this column and this column and this column and that column, basically all the columns in the table. If you notice in the right-hand side, the left-hand side of this page, we kind of have a enumeration of all the columns for each table. A table of customers has these columns here. So when you say star, you're saying, I want to see the value for all of these columns. Now, if you want just a specific column information from a column, maybe I only care about somebody's last name. I can go here instead of star, I can say last underscore name. That's the exact name for the column here. And you can see here as well. And I click run. What I'm going to get is the last name for each row. So you can see the first is Doe, the second is Luna, so on. Now, what if I want first and last name? Well, that's easy. Just separate them by a comma, okay? So I can either put before or after. Let me put at before. So I'm going to say first underscore name, then add a comma there. And I click Run SQL. You're going to see now I get the first name and the last name. Okay, I usually like to add a space after punctuation, like comma, but that's not required. It's just for me to better visualize things. Does anybody have any question? You can always post to comments there. Let me see if question you keep putting underscore. Is that needed? Yes. So you have to pay attention. Every character matters. The casing matters. So if you see this column name here, the column is literally first name underscore name. So you have to use the underscore there. So different SQL implementations kind of have their own naming convention. In this case, they are using of underscore case. So meaning every word that you have, you're going to separate it with underscore. If you had like without the underscore, for the programming languages, it's kind of difficult to have a space because it would mean like two different things. So that would be really confusing. So that's why we always put something to separate the words, or you don't have to put anything. There are some naming conventions where all you have to do is capitalize the first word, the first letter of each word, like Pascal case in Microsoft SQL Server. Okay, but you gotta have the underscore. All right, more questions. Pretty much a data repository, client company, store the data. What's the purpose of semicolon? Semicolon here is always needed at the end of every statement in SQL. So I forgot to let you know about that. So in SQL, all the commands have to end in a semicolon. That's just for the syntax of the language, okay? So make sure to add that semicolon at the end. Implementation of the database will determine how you query information in it. I'm not sure your question, Maggie, but every database has their own implementation of SQL. That might not necessarily be the same. I do not know the internals of the database implementation here. So that's something you don't need to know, how the database is built, run internally. You just need to know the language called SQL in order to interface with that and be able to manipulate or get information out of it. Can we use like first name plus last name? That's called concatenation, and it is possible. There's a function there are functions that you can use to concatenate things. But the way I did things right now is separate columns, okay? But if you're interested in that, I think it's called concat, and you would call it here, like this, and pass the arguments and finish with like this. Something like that. Just look it up and you eventually find something. Okay, so I'm going to continue. So let's talk about country. Okay, where are the countries? So if I want to select only the countries from these customers, I would write here, select country from customers. So I know where my customers are from. So you can see I have a customer from USA, another one from USA, another from UK, then UAE. As you can see, it repeats, right? Because I have one person per row, even though you don't see their first last name. But this is kind of sucks. But if I have like a lot of people, 1 million people, there certainly isn't a million countries, right? So I want to be able to see a list of all the countries my customers come from without necessarily having to go through all the 1 million rows. So in order to do that, you should do distinct before the column name here. So what this does is it groups every duplicate into a single row. So if I click Run SQL, I only see unique country names. That way, if I had 1 million rows, I don't have to go through every one of them to see who is from what. If I do distinct, I can consolidate into probably at most 190 something countries, right? There's no more than 200. Somebody asked the question, I want to know the way you query information is SQL standard regardless of how it was implemented. Yes, like I said in the beginning, SQL is a standard language. If you know how to write SQL this way we're writing, you can do pretty much any SQL database because they all follow the same patterns. It's a standard. They just implement, when I say implement, it just means they construct the thing you're going to use. It's like a blueprint. You have a blueprint from a car, everybody's going to follow that same rules. But the blueprint by itself don't necessarily let you drive, right? Because you need somebody to build a car. So SQL is like the blueprint, and the companies have built the car, meaning their own cars, right? We have different kind of makes. So they each have their own variation, but they all follow the same pattern. So we can all drive over a wheel, we can brake and throttle and so on. All right, so moving forward. Okay, let's talk about looking somebody up, because so far we're always querying all the rows. And that's not really what we do. Let's say I want to find information about somebody who might have the last name Doe. So let me put star back. So I want all the columns from customers. And I'm going to teach you about the where clause. So you can add, after the from, you can add where if you want to narrow it down to specific rows. Like I want to say where the last name is equal to Doe. So what this means, okay, I'm going to select the rows from the table customers, all the columns, but I only want the ones that have last name equal to Doe here. Click run, and you can see there's two customers, okay? You can see their last name is Doe. So where is very common. Don't forget, you can just say the column name here, and the equal sign, it means to compare, okay? Some programming languages, this is like assignment, but this is not the case here. This is actual comparison. Okay, but what if I want to look up by first name as well? Okay, I found two customers. Actually, I just wanted to find out about John. So how would I narrow down it even more to just a single person? Well, I have to say and another comparison. In this case, first name equals to John. Now I want to do something here real quick. I'm going to put lowercase j. Let's see what happens. Well, I got nobody, no rows. Why? Because I typed lowercase j here, and that's different from uppercase j. So be careful. The case matters in this case. Think about that. Okay, so you can basically follow the same pattern and keep saying and column name equals something. And column names equals something. Now you might have noticed I put quotes around the name. Why did I put quotes? This is called the string in programming language, okay? Because I want to literally say the word or the string of characters DOE. Okay, if I put it without, it might think it's something else. Like usually in programming languages, we have reserved keywords like the select here, right? And the from and where. They're special keywords. And if I put it without the quotes, it's gonna try to think it's a special keyword or some kind of variable or something. So always make sure if you have the literal text, you have to add the single quotes around it in the beginning and the end. Somebody asked, can you compare by ID? Yes, you can compare anything. If you want to say by ID, you just say customer ID equals some number. Now, in the case of number, you probably don't need to say the quotes around it. For example, let me just do it real quick. Where the customer ID is, say I want to find the customer ID 3. Let me see. As you can see on the left-hand side, it tells me what's the kind or type of the column. Customer ID in this case is int. Int is short for integer. So in that case, I don't have to have quotes. I had to have quotes for the other ones because it's a varchar, meaning character varying string, okay, of 100. And there you go. In this case, because that's an int, a number, integer, I don't have to have the quotes. But as you can see, I can find by ID. Yes, it's called case sensitive. Somebody said, yeah, the case matters. Somebody commented, what if you wanted John and John? So if you want these two, so first you would have to say first name, John, to get both of them, right? Now there could be a third John. Do you care if there's a third one? If you care about the third one and you specifically just want these two, even though there might be other Johns, then you got to narrow it down even more. But you can say like this, instead of saying and, you can add the, let me show you real quick. It's a little bit nested things. So, and the last name is either Doe or last name is Ryan. Let's see if that works same way. So in this case, I have to say, okay, first name is John and something else, and the something else is, I have to use an or here, which is like the opposite of and in a way. The last name is either Doe or last name is that one. So that one, you just capture those two, assuming there are more Johns. Okay, so that's a little bit of a nasty in there. I didn't want to go that far. Might confuse some people. Nice. We talked a lot about querying data, like finding out information, but can we manipulate the data? I mean, can we add more records? Can we update them? Can we delete them? Let's talk about inserting new records. So when you talk about adding a new row, we talk about insert. So we're going to say insert into customers values. And then we're going to put some parentheses, semicolon here. Now the syntax is always like this: insert space into, and then table name, space values, and some parentheses here. And within the parentheses, you gotta specify the value for each column in order. Okay, in this case, you have to have the order. So the first, you look up in the left-hand side, you can see the customer ID is the first one. So as you can see, there's already a 5, so I'm going to add 6. And then if I want to separate these column values, I need comma. I like to add a space after comma, but that's not necessary. Okay, now I need, what's the next column here? After customer ID, there's first name, right? So I got to write the first name within quotes. Let's say, I don't know, let's say somebody, Anna, and then comma. Now I need the third. Well, that's the last name. So last name, I'm saying long. And then the fourth column here is age. I'm going to say 21, comma. Now the next column is country. Let's say Canada. Now let's click run. See what happened there? If you notice, we now have a new row in the column customers. So typically when you have databases, the ID column usually auto increments for you, so you don't have to specify it. But here it's not really, I don't think it works that way in this environment. So I have to specify the ID there. You might be asking, okay, I have to always follow the same order. What if I don't know, for some reason, I don't know the order of the columns? Obviously, if you have access to the database, you're going to know the order, but let's suppose you don't know. You can always go here before values. You can specify the column names here. Let's say I say customer ID is the first, but then let's, for some reason, use last name before the first name. And then age and country. So make sure to specify all the column names separated by a comma. Now you might notice there's no quotes around them because they're a special thing, they're column names. So no need. Now, if you notice, I put last name before first. Now, if I do this, I got to swap these two because this one is for the first one here. So they're all like corresponding in order. The last name in this case would be Anna, which is wrong. So I would have to swap this one with that one there. Like, make sure the syntax is correct. And I put in a new row so you can see better. The line break doesn't matter, okay? I can break it into a new line, and that won't change a thing. I just made it so you can see it better. You might have noticed I'm typing everything in a single line, but you don't have to. Usually the SQL queries will be very long, so you can break them down in multiple lines. And there's usually a convention for that if you want to follow. But okay, what happens if I do that? Oh no, if you read the error, unique constraint failed on the customer ID. So it says table name dot column name. You're gonna see this a lot. So unique constraint. So the column customer ID has a constraint called unique, meaning I cannot have a same row of different rows with the same customer ID. So that's important because it has to be something unique so that every row has something unique you can query for. So since I cannot have that there, I'm going to put 7 here. Now, if you notice, there's no protection about first name and last name. It can be the same. You know, probably in the world, there are people who same name, right? So I wouldn't add a unique constraint to the names. And probably they could have the same age and same country. That's totally possible to have these kind of things. They could be the same, different people by the same name. Okay, and if you notice, the last name is the same, even though the order here was changed. So if you need to order any way you want, just specify the column names here and order any way you want, but make sure that the values right-hand side here is corresponding in order to the names that you wrote. Anybody have any questions? Is ID always the primary key without specifying it? No, you have to specify that a column is a primary key when you make the SQL statement to create the table. Because we are in this environment, the tables were created for us automatically. But in the real world, when you have to make your own table, you're going to write a statement called create table. And then you're going to specify each column. And there you're going to say, is this column primary key or not? So you have to do it. But if you're using any kind of framework for programming, like a web server, what we call ORM, Object Relational Mapper, they conveniently have all these things like built in for you. So you probably wouldn't have to do it manually. But in practice, it's behind the scenes. It's there. Somebody had to add it. What is varchar 100? So every column has a type in SQL. Like you can store numbers, right? You can store text. You can even store binary files like I don't know, images or whatever. So if you look at the left-hand side here, customer ID is an int. Int is like integer, which stands for just a number. That's an integer, right? 1, 2, 3, and so on. And then first name is varchar 100. Varchar is a character varying string, meaning it's a string of characters that vary in length. So I can have 1 character, I can have 2, I can have 3, and so on. But it has to be a limit, right? How many characters can you have? That's what you put in the, usually what the 100 there is for. It's to specify kind of a limit. Okay, I want this varying character, but how far can you go? Can I have more than 3 characters? And so on. Yeah, look up the docs varchar, and it will tell you there what the number. if you have more information. Some of them are that different kind of things depending on the type. How to sort data in a specific order, ascending or descending. We didn't talk about that, but there is a way. I can show you right now, even though I wasn't planning on talking about that. So let's say you can see now the columns start from customer ID 1 up to 7, right? What if I want to reverse that? So I can say select start from customers, and this will give me the table as is. Now, if I want to order by some column, I add order by here. Literally the word order space by. And then customer ID is the column I want to order by. But then I gotta say, is it ascending or descending? By default, it's ascending. But if you want descending, DESC, which stands for descending. So as you can see, now I have the rows descending by customer ID column. Okay, so that's the order by. Let's talk about deletion. I added 2 records here, and I don't want like them. I want to delete them, 6 and 7. Now, before I talk about delete, I want to remind you, be careful delete, because you might delete everything. So I'll show you how to not delete everything. So we're going to say delete from, and then you see the table name. In this case, customers. Now, if I say like this, delete from customers, everything will be deleted, all the rows. So be careful using this. So you always want to put a where there to narrow it down to one thing usually. Okay, let's say I want to delete from customers where the customer ID is 6, because I don't like 6, I don't want 7. So I can do here customer ID is 6. This is the most common way of deleting, right, by the ID. And the safest thing to do, right, is just delete one record if it exists. So if I do that, it's gone. The row with the customer ID 6 is gone. Now I could also delete by other columns. For example, I don't want 7, right? I could say last name long, but I have to be careful. This is not good. Okay, I'm telling you about this just for practice, but usually this is not a good thing because there could be other people named long, right? So if I meant to just delete Anna here, this very unique row, and there were other people's named long, they would also be deleted. So be very careful. You usually just want to delete by the ID. That's the safest way, because you just delete one thing, because the ID is unique, right? Primary key, there's only one row of that ID. Okay, so that's pretty much how you delete. Delete from table name and add a where there and specify usually the ID is equals. So what we're going to talk about next is how to update records. Okay, so to do that, we're going to use update. So you say table name and then set and then whatever you want to update. For example, country equals Canada. Now you got to be careful here too. If I say update the table name customer set country to Canada, that means every single row will be set to country Canada. So it's the same thing, delete. Make sure to add a where there to be specific about which row you want to change. So let's say for some reason Robert Luna won't move to Canada. So customer ID is 2, that's Robert Luna. You remember here? And if I do that, he's now in Canada. So make sure to add a where there, otherwise you're going to update everything. And that's pretty much how you update anything. Just after the set, you specify what columns you want to update. And then here, some narrow down, some filtering to make sure you don't change everybody's rows by accident. So that's pretty much update, everybody. I don't have anything more to say about update. If you have any questions, let me know. Otherwise, we just keep going. You want to try what happens when I see without the where? Click run. Everybody's now from Canada. Let's see what happened. So that's really bad. So I'm gonna refresh. So I gotta reset everything. So their countries are reset. Obviously, in the real world, you don't get this reset like I just did. So be careful. Is there an undo feature, or do you have to redo the entire database? Yeah, so you have to be careful about database. Usually people keep backups. That is every few moments in time, it backs up the database to a certain point in time. So you could technically try to bring it back to a certain point in time. You know how people might do really bad things to the database, so that's how you recover. Now, if there's an undo feature, I don't know. There might be a way to, like, I know database, you can log everything you do. So there might be a way of kind of going back to a previous snapshot. Now, if you're working with programming languages, typically what you do is what's called a transaction. You try to do something, but if anything fails, it will just revert back, what's called a rollback. But that's just on the application, like the client side, not in the database itself. If somebody were to manually go into the database and try to do stuff, that's another matter. Can we export, import data in SQL? Absolutely. You can always make what's called a dump of the data, and there are different kinds of dumps. Usually you can do that with a command in a command line. Any of your database servers, you can do that. Okay, that's nice, but how do we know? Let's say we have David here. Let's find out what he ordered. We have a table of orders, so that's like you're in a store. You're going to keep track of all the orders. Let's understand, okay, what did he buy? So how would you do it? Well, the easiest way is look like you get his customer ID is 3. So you're going to say, okay, select all the columns from what's the table now? That's orders. Where the customer ID, notice we have the column customer ID in order, and that's 3. Make sure, usually we always make sure that the customer ID here points to the ID of the customer column. So you can see David Robinson, customer ID 3, he only bought a monitor, no more orders. Now, this thing here is called a foreign key. When you have a ID in another table, that is mapped to this table here. In this case, we have orders, and we have a customer ID. For the customer ID here is a foreign key that points to the primary key of the customer's table. This is a very common pattern you're going to see all over the place. We don't usually like mix table data together. Obviously, you could have the orders table, have the first name, last name, age, and so on. But that's not good practice at all. We need to separate the data. So we have a table dedicated for customers and one for orders. And if you need information about the customer, like their first name, last name, whatever, you just got to look at the foreign key here in the orders table, and then go to the customers table and find a primary key that matches that. In this case is with 4, right? So John. Now I'm going to talk about how to include that information. Obviously, this is not useful if I'm going here, okay, customer number 3, who is 3? I don't know. So I don't want to manually look up in the table customers. I want this to already show me the first name, last name, and so on. That's a very common thing we do, and that's called a join, SQL join. We're joining tables together. Okay, so I'm going to go here. I'm going to say inner join. That's a kind of join, right? Okay, there are different kinds of joins, but this one is inner join. They're going to match the customer ID in orders with the customer ID in customers. So we can exactly know every single order for that customer and their information. Okay, we got to say, okay, you want to join with what? What table? Customers table? And then on, that's a keyword. You got to say how you want to match. Okay, I want to match the customer ID of one table, that's orders, with the customer ID of the other. But notice here, both tables have the same column name. How do I know which one is which? So this is ambiguous. So how to find a way of, disambiguate here. So I can prefix these with the table name. So, okay, let's say customers dot customer ID. Oh, okay, so we're saying the customer ID column from the customers thus match the orders dot customer ID. So that way we know, okay, it's this customer ID here from customers has to match the customer ID from orders. Now I'm going to move the where to the ending, okay? Because of syntax. So make sure to move your where to the end after you did the inner join thing. Now if I do that, oh, what happened? Same problem I had, the ambiguous, right? Where customer ID is 3. In this case, it doesn't really matter which one I pick. So you can say here either customers or orders. And there you go. Now what happens is it takes this record from orders, and then it kind of puts side by side with what it matches for the customers table. As you can see, the left-hand side is from orders, and the right-hand side is from customers. Now I want to show you customer 4, because customer 4 bought 2 things, right? If you notice from the order table, he bought a keyboard and a mouse. So if I use 4, we're going to get 2 rows, because we have the one for the keyboard and one for the mouse. But observe that each of them on the right-hand side, they get their own copy of the customer row. The single customer row for John appeared twice because we have 2 rows from order. Does anybody have any questions? Can we do distinctive situation? I know what you mean. Yes, you can group by things depending on what your goal is, right? You can consolidate these into one row. And I'm going to show you a way just now. But there's no need to, whether you consolidate things is independent of you having a join table or not, right? So we can consolidate into a single row. But the point here is you don't want to consolidate because you're trying to figure out the orders, right? If you consolidate into one, you're going to lose keyboard and mouse. What are you going to do? You don't know the orders. So the point here is not to consolidate. But if you need to consolidate in another situation, yes, you can. And I'll show you how to count things in a moment. So if I remove the where, this is going to happen for every customer. So we got all the orders and the customer information side on the side, okay? Now we can see all the orders and the customer, what they bought, joining the 2 tables. And this is not narrowing down to anything. Now I'm going to talk about counting things. How can we find out how many keyboards we sold? One way is to go to the table. Okay, you got orders. Let's count. Okay, 1 keyboard, 2 keyboards. Nice, 2, right? What if there were 1 million orders? Would you do that by eye? Obviously not, right? So you want the computer to count for you. So how can we do that? Well, let's say select star from orders. If I just did it this way, I got to do by eye, right? Another way could be, okay, where the item is keyboard, still by eye, right? But a little better. If there were 1 million rows, I would have to count the 1 million rows, right? By eye. So let's make the computer count. We're going to say count, parentheses star here. Now, if you do that, we got 2. So that's as easy as adding count there. So when you say count, star, close parentheses, this is going to count the number of rows. It's not going to give you the rows, but rather how many rows were found with this query. So there were 2 orders of keyboards. So using count, you can count anything. Maybe I want to count how many customers I've had. Select, count, star with the parentheses around. From customers, and that will give me how many rows for customers I have. And you can see it's 5. Notice I have 2 separate queries, and I can run them, and it will give me 2 separate outputs. The second one is for the customer count. Now, you might notice there's this count star here. If I'm reading this, I'm like, okay, obviously I have the query. What if I didn't see the query here, and I only saw the output? I don't know what 2 is, what 5 is. So usually people can add an alias to rename this heading. So I can say here after the count star, as, let's say, keyboard sales. And if I do that, instead of seeing count star, I'm going to see keyboard sales in the table heading. And I can do the same for customers, as customer count. That way, it's clear to me what the output is if I only look at the output. Okay, that's called an alias. You can alias any column you want. Just make sure to add an as to the right-hand side of the column name or whatever operation, in this case, a count. And And I'm talking about the select area, okay? Keep that in mind. If you want, notice I put the words together. If you want to separate by a space, make sure to add a quote surrounding it. If I want a keyboard space sales, you can do that, but add the quotes there. You know, programming, usually, if you don't have the quotes in this case, it would treat us two separate things usually. I don't know if this would work. See an error, right? Because it doesn't understand what this is. Two separate things. So we need the quotes there. Now, somebody asked about grouping things or making distinct. And I want to show you a way of grouping. Let's say I have select star from orders. That gives me all the orders. Let's say I just want to group the rows by the item. Because I don't really care about the information. I just care that I can see the item names. I can do group by here and the column. And see what happens there. You can see all the rows for keyboard consolidated into one. We had two for keyboard, right? Obviously, this example, I would have to add more rows here so you can better see what it would do, but every single item for keyboard is consolidated into one single row. Now, you lose information about the amount, right? Because it only takes the first one. So that's why some cases you don't want to do this. This is only appropriate if you don't care about this information being lost. Like this one's for the customer ID 4, which is this one, but you lost the information for the one, customer ID 1 here for the keyboard. But this is called group by, and you can group by anything. We could group by, I don't know, customer ID for some reason. Then we consolidate the orders in customer ID or amount, okay. Group by amount. And you group everything by the amount. But it's more, I think it's more useful to group by the item here. Yeah, so this is kind of similar to distinct in a way, right? You could also do select distinct item, right? That's another way instead of group by. So you could also do it that way. Yeah, so I think distinct is very easy. So whenever you can use distinct, use that. But if you can't use distinct, you can group by. That's more complex for more complex stuff. Okay, everybody, I think I've reached the end.